Welcome to Logos Live. I'm Robert Martin, Director of the City Bible Forum in Melbourne, and I'm your host for the show. Logos is Greek for word or message. Logos Live seeks to engage the Christian message in Melbourne. Yet today our show doesn't come from Melbourne, instead I'm in the UK. So this also means that we're not recording before a live audience. So today's episode's a little bit like Logos pre-recorded, but nonetheless I'm sure that you'll enjoy what we have in store. And today we're in for a treat. My guest today is the Reverend Dr. Rodney Holder. Rodney holds a D.Phil in astrophysics from Oxford University. He also worked for the Ministry of Defence. He returned to Oxford to gain a first-class degree in theology and then worked in parish ministry for many years. He has written many books exploring the interface of Christianity and science and was the course director of the Faraday Institute. Dr. Holder is a member of the International Society for Science and Religion, the Society of Ordained Scientists, and the Science and Religion Forum. He joins me now. Welcome, Rodney.
Thank you.
You have a distinguished career in science. Can you tell us a little bit about your work, what you've done?
Okay, well, I read mathematics first in Cambridge.
What does it mean to read mathematics? You read out numbers, do you? Is that what happens?
It's just the technical term for studying a subject.
Okay, right, okay. Yeah.
So I did that in Cambridge, and the great thing about the course in Cambridge is that you can specialise in mathematical physics, theoretical physics, and in particular in the fourth year of the course, postgraduate year, you can do astrophysics and cosmology and general relativity, these wonderful subjects. So I did that. And then I went to Oxford to do a doctorate and a postdoctoral research. My subject was accretion of intergalactic gas by the galaxy, which sounds a bit esoteric.
I'd almost need to do a PhD on that sentence, on that title. What does that mean? What happens?
Well, intergalactic gas sort of permeates galaxy clusters, and one of the things that was wanting to be known was how much of it there was, because an interesting question, we're talking now about the 70s, but the same question is still around. It's basically how much stuff there is in the universe, what its mean density is. This is an absolutely kind of critical question. And so that research sort of impacted on that. What were the limits on that? I mean, it turns out that many years later, we now know that, well, there's nothing like enough normal matter to satisfy all the equations and everything and the observations. Right. So basically 5% of the universe is normal matter, and about 25% or more is some kind of unknown dark matter, and then there's this mysterious dark energy, which is about 70%. So nobody really knows what these other things are. But that's the sort of big picture impact of my research, though of course it was much more detailed in terms of what this intergalactic gas was doing. But the important question that it's related to is to whether the universe is eternal, whether it's going to expand forever, or whether there's sufficient stuff that gravity will pull it back and it'll crunch. Yeah.
Yes.
So, and in fact, what we now know, is that it's really literally at the balancing point there,
right,
very close to the tipping, the tipping.
So it could point. Crunch back, or it could continue expanding forever, but no one's quite sure.
Well, that's right. Most people think it will expand forever now, but it's still a bit of a moot point. We could still be in a finite universe. Well, we could be in a finite universe now that also expands forever.
Right.
So we don't quite know for sure whether the universe is infinite or whether it's finite. And indeed, that's maybe an impossible question to answer, because measuring the mean density of stuff for an infinite universe, we can't.
It's very difficult to actually get a final number.
We simply can't do it. But one of the interesting things I've worked on more recently in terms of my interaction between theology and all this Big Bang stuff is the fine tuning.
Yeah.
And one of those fine tunings is the fact that the universe is so close to this knife edge. It needs to be, otherwise it will expand far too fast for anything interesting to happen, any galaxies to form, any stars to form, and so on. Or it will recollapse far, far too quickly for anything interesting to happen, in the space of months or years. Right?
Yeah.
And of course, people argue about and there are a whole host of these particular fine tunings. That one people may think they've solved by a theory called inflation, which predicts that the mean density will be very near this critical value. But on the other hand, it seems to me that if certain fine-tunings are solved in that kind of way, then the question is pushed up a level as to, well, why does that particular theory apply that has that effect that means that we can be here?
Yes. So, we'll get to talk about fine-tuning in a second. Let's go back to astrophysics. Sounds very science fiction, NASA, spacesuits, intergalactic. Is that what it's really like?
No. Astrophysics is really about studying stars, galaxies, so there's an observational side to all of that, with the looking at the light, the spectra of the light that comes into us, there's a whole story that I wasn't involved in, say, for example, to do with how stars form and evolve, and we've got very good models of all that now, life cycles of stars, galaxies themselves, different kinds of galaxies and how they form and evolve. There's a lot of complex mathematics and physics involved in all of that, and there are a lot of the data comes from satellites, from ground-based and space-based telescopes and so on. And then there's a lot of theoretical work going on as well. And the area that's particularly interesting from the point of view of theology is cosmology, which is that aspect of astrophysics which is talking about the universe as a whole, how it started, how it as a whole has evolved and so on.
And changed.
Yeah, exactly.
Well, again, we'll talk about that in a second. But I'm keen to hear a bit more about your own personal story. So you're a Christian believer.
Yes.
So what convinced you to become a Christian?
Well, that was hearing the gospel, basically. Preached, and preached very effectively and convincingly when I was 18 and a new undergraduate here in Cambridge. There was a guy called John Collins, who was very well known in England, and became more well known after later, associated with Holy Trinity Brompton and so on. Now retired. I've never seen him from that day to this. Right. But he preached a terrific sermon, and I gave my life to Christ.
Right. What was it about the message that was particularly attractive to you?
Well, it was the person of Jesus, what he'd done, died for me and so on, and died on the cross. And this is still, for me, absolutely fundamental. More fundamental than anything else, any of this abstract stuff to do with astrophysics and so on. That's still the heart of it for me. I think it's important to say, though, for someone who is a scientist, that one is concerned about evidence. And one is concerned that maybe a slightly emotional conversion event could be, that could be maybe psychological or something.
Something inside the mind.
Exactly. So, but for me, it stood the test of time, and it's nothing about my science. Far from it, the opposite has confirmed everything about it. My reading theology much later on has been much more confirming. My experience of worship and being involved with the church, everything has reinforced the faith rather than undermined it as the years have gone on. I was 18, now I'm 64. So
there's a lot of reinforcing.
Reinforcing, and greater and greater conviction. But the heart of it for me is the cross and the resurrection of Christ.
Well, let's talk origins. It's your area of your speciality. So, with current scientific theories, tell us what happened.
Well, the Big Bang is actually pretty well established as a theory. You may or may not know, but it's the brainchild of a Roman Catholic priest.
Goodness.
Whose name was Georges Lemaitre.
Yeah.
And in fact, he was a member of St Edmund's College, in Cambridge, my very own college.
Right, wow.
In the year 1923 to 24, he came to work with Sir Arthur Eddington at the University Observatory, and he was based at St Edmunds, where he could say daily mass as a priest and so on. And he was a great cosmologist. Now, what he did was he solved Einstein's equations of general relativity. That's Einstein's equations of gravity, basically.
So he would have probably won the first prize in his class, I suppose, for doing that.
Yeah, well, it was utterly remarkable. There was a Russian who did the same sort of thing slightly earlier, called Alexander Friedman, but who didn't think this applied to the universe. It was just a mathematical game.
Right. Whereas
Lemaitre thought, this is the way the universe is. And so he predicted the expansion of the universe. This was in 1927. That expansion was observed by Edwin Hubble in 1929. So in this first model that he came up with, it wasn't really a proper Big Bang model, but it was an expanding universe model from a finite-sized, quite substantial-sized universe. But then in 1931 he came up with a model where the universe started from a very highly compact state and it basically exploded into the Big Bang that we more or less know today. He called it the primordial atom himself, and it was later called the Big Bang by a Cambridge astrophysicist called Fred Hoyle. That may or may not have been a term of abuse, but certainly Hoyle didn't like it. Hoyle was an atheist, and he thought, goodness, if the universe had a beginning, then it might need God to create it. So that was a big problem.
So he believed in a sort of a steady state.
Precisely.
Universe.
He came up with an alternative called the steady state. This was in 1948. And from about 1948 till 1965, these two theories were rivals. The interesting thing was that in 1948, a team in America made some predictions on the basis of the Big Bang. A difficulty that we had was explaining where the helium in the universe came from. The universe is basically 75% hydrogen, 25% helium, with a tiny sort of fraction of other chemical elements.
So that we are made up of.
Yeah,
so
the really important ones.
So we're the minority part of the universe.
But basically, on the basis of the Big Bang theory, where nuclear reactions could happen because the universe was very hot in its very first few minutes, this helium could be made, and indeed it was predicted by this American team. Hoyle's method for making elements, which is nuclear reactions in stars, which are also sites where it's incredibly hot in the cores of stars, couldn't do that, couldn't make the helium. Could actually make all the other elements. And so, in fact, that was a nice synthesis of where the chemical elements come from. But the other really important thing, of course, that's the expansion, but of course the steady-state theory explained that away, essentially, by saying new matter comes into the spaces between the galaxies as they move apart, and, lo and behold, at just the right rate, that the universe, well, for them, stays the same yesterday, today, and forever. The other major prediction of Alpha and Herman was that if the universe started hot and dense, then by various processes what would happen was that it would cool down, and after 13, 14 billion years, it would have cooled to a temperature of around about 5 degrees above absolute zero. And the absolutely terrific thing was that this was observed in 1965 by Penzias and Wilson at Bell Telephone Laboratories in the US. They thought they'd got bird droppings in their antenna. What they'd got was the leftover noise radiation from the origin of the universe. That was a staggering discovery. They had to be told that by other astrophysicists.
They thought they had a mistake.
Yeah. They thought there was noise in their antenna. Anyway, so that was an absolutely staggering discovery. The steady state couldn't explain that.
Yeah.
But also, the steady state was also already being undermined by another kind of observation. If you think about it, if the steady state is correct, when you look at the universe, it should look the same it should look the same yesterday, today, and forever. So if you look at distant galaxies, you're looking at the universe as it was millions and billions of years ago. It should look different. It should look as though it's evolved. If there's a Big Bang, it should look identical. The distribution of galaxies should be the same in particular. And that was found not to be the case by various observations in the 50s here in Cambridge by the radio astronomer Sir Martin Ryle. His earlier observations were a bit dodgy, questionable, but by the early 60s they were really getting firmed up, and it was looking like they were eliminating the steady-state theory. So it eventually died, and the Big Bang reigned supreme from that time. Now, of course, that isn't the end of the story, because that's the basic paradigm against which all kinds of modern, more speculative theories, which sort of modify it in various ways.
Because basically you've alluded to a few times, it seems as though you've got two options. You have an eternal God who creates, or an eternal universe which remains.
Yes.
So now that the scientific evidence points towards a universe with a specific starting time, people have now sort of suggested, well, perhaps there's an eternal multiverse.
Yeah,
which means we don't need to worry about the fact that there is a creator, because, well, the universe is just there. There's just lots and lots of universes kind of popping into existence all the time. Yeah,
now there are all sorts of questions there, because I would want to qualify the theological point here. God can create a universe with an infinite history in time. The verse you wanted to refer to...
Part of Logos Live is we refer to the Bible, the Logos. Hebrews 11:3 is the one that we look at. And so I'll read it out. By faith we understand that the universe was created by God's command, so that what is seen has been made from things that are not visible. Your reactions to that?
Well, my reactions to that are that this is one of very few verses in the Bible which point to a literal creation out of nothing.
It's not creation.
Yeah, exactly. It's not clear, even in Genesis 1, that God isn't creating out of
pre-existing material,
pre-existing kind of chaos.
Yeah.
I mean, God is in utter control in contrast to Babylonian or even Plato's kind of idea about that, where matter is resistant to the creator, the craftsman who creates in Plato's Timaeus. Now, whether there's an origin or not is an interesting point, and St. Thomas Aquinas had something to say very much, sort of based on the Hebrews passage. He said that you cannot establish that the universe had a beginning by reason. He believed it by faith, just as this verse says. But Aquinas said you can establish by reason that the universe needs a creator, nevertheless, because even, and he has his 5 ways, his 5 arguments for the existence of God, and basically, even if, and they're not to do with temporal origin in time, but they are much more to do with ontological origin. If there is an infinite sequence of cause and effect that goes back infinitely far in time, that needs God to create it and for it to exist at all.
A first mover.
Precisely.
Or an unmoved mover.
Precisely. It needs an unmoved mover. So in some ways, even if there were an infinite universe, which is something that it's going to be very, very hard to establish, then that is not a problem for theology. And indeed, many theologians basically take that creation ex nihilo doctrine to mean that the creation is dependent on God's for its existence. It's brought into existence and upheld in existence moment by moment by God.
Some would say that the unmoved mover is the multiverse.
Even if it were infinite, this point about God needing to create it would still apply, whether it's a multiverse or a single universe. However, there are some very powerful theorems at the moment produced by a great cosmologist called Alexander Vilenkin, who has shown that under very general conditions, all the major models of cosmology that are on offer at the moment, including these multiverse-type models, backtrack to a beginning. Now, there was a very interesting event at the beginning of 2012 to celebrate Stephen Hawking's 70th birthday here in Cambridge. There was a symposium in his honour. Very sadly, Hawking was ill and couldn't make the symposium. He had one of his periodic stays in hospital. He's obviously extremely ill and extremely disabled. I mean, he has a fantastic mind, there's no doubt about that. But he sent a message from his hospital bed to the symposium saying, if the universe had a beginning, then it would need God. This is a big problem for atheist cosmologists, much less a problem, as I've just explained, for theologians. But anyway, Alexander Vilenkin was there at the symposium. He gave a lecture in which he said that all the evidence we have says that the universe has a beginning. So it's a tremendous irony.
Wow.
So, for example, there are these models of inflation and universes which bubble up out of a sort of background space, and you have eternal branching universes and so on. Well, perhaps into the future, but according to Vilenkin, they will backtrack at some time in the past. It might be, on our time frame, trillions of years, who knows, but they will backtrack to a beginning point. So that's where cosmology is at the moment. That's where the evidence is pointing.
So by deduction, from Hawking's own statement, if Vilenkin demonstrates that the universe has had a beginning, Hawking's suggesting that the only explanation for the beginning is God, then
exactly.
He's unwittingly suggested that there is a God. So why doesn't he accept the implications of his own logic?
I don't know quite why he's really an atheist. Many of his colleagues are not, that's for sure. There are people in the Department of Applied Mathematics and Theoretical Physics where he works here in Cambridge who are certainly not atheists.
Let's just think a bit more about fine-tuning.
Yes.
It's another area of interest of yours. Tell us about what does it mean to be fine-tuned?
Yes, this for me is my particular area. I've thought a lot about it. There are many, many examples of it. It's basically the way that the universe seems to have been set up at the Big Bang, so that it gives, a smooth universe, a universe that's long-lived enough, that develops galaxies, stars, and life. And there are many conditions needed for that. I mentioned one to do with the density. There's another to do with the force that causes radioactive decay. It has to be just right so that you don't get all the hydrogen turned into helium. I was mentioning that earlier on. It's to do with also the strengths of the various forces of nature. There are four main forces: that radioactive force, there's the force that binds atomic nuclei together, there's the force between charged particles that causes electricity and magnetism, there's the gravity, of course. Okay, so these need to take the relative strength that they do in order for the universe to give rise to life. And a very famous example is due to none other than our atheist friend Sir Fred Hoyle. In order to have life in the universe, you need carbon and you need oxygen. And these are made in the hot interiors of stars, as I was explaining earlier on. To make carbon is extremely difficult. What has to happen is you have to crash together 3 helium nuclei and you have to make them stick. The problem is that the intermediate element, 2 of them crash together. Beryllium is unstable. It lasts for 10 to the minus 17 of a second, a tiny, tiny fraction of a second. So you've got that fraction of a second to crash the third one on. This needs an enhanced effect to make that reaction go. It's called a resonance, and it's a value of an energy level in the carbon atom at just the right point. People didn't know that level, there was an energy level in carbon at that point. Hoyle predicted the precise value. Colleagues in the US discovered it, measured it. I got the Nobel Prize for it.
Right.
Hoyle sadly was left out.
Poor bloke.
Yeah, I think he was not someone who made friends too easily. He'd already upset, I think, the Nobel Committee for various reasons. But it was a bit unjust. And actually, in St John's College Library here, there's a wonderful letter from Fowler, his colleague who made this discovery, saying how regrettable it was that Hoyle wasn't included in the prize. He was really sad by it. He had to accept it, on behalf of his institute and everything else, which I'm sure is correct. But he was very sad. Anyway, but to go on with this story, the other thing you need, the other element you need, is oxygen. And to make oxygen, you need to crash another helium nucleus onto the carbon one, but you don't need to destroy all the carbon in the process, because then you lost the opportunity. Carbon's the only molecule that'll make, the only atom that'll make long chain molecules like DNA and so on, proteins, DNA, and all of the rest of it. You need carbon, you need oxygen. So that means that there doesn't have to be an energy level. The energy level in oxygen has to be much lower and so on. And Hoyle made a prediction about that too. The significant thing is that when Hoyle made this discovery, he said that the universe is a put-up job. He says, a super intellect has monkeyed with physics as well as with chemistry and biology, and there are no blind forces worth speaking about in nature. And that is where the evidence took him. As a militant atheist, broadcasting on the BBC in the late 40s, early 50s, saying religion is an illusion, it took him from that position to saying that there's a super intellect behind the universe. He couldn't, of course, bring himself to use the word God. That's just going a bit too far. But a massive change in him, and it's all to do with the strength of the strong force of nuclear physics that holds atomic nuclei together. The strength of that, you adjust it by 0.5%, you've lost it. And then there are a whole host of other coincidences.
Coincidences or on purposes?
Well,
perhaps?
precisely.
It depends on
precisely.
Yeah. Well, Rodney, thank you so much for your time here today. It's wonderful to have you on the show. And I'll close with the Logos, the word of the day, which is Hebrews 11:3, which says, by faith we understand that the universe was created by God's command, so that what is seen has been made from things that are not visible. Thanks once again.
Thank you very much.